Hello, everybody. Yeah, thanks for the team behind Mobile Warsaw for having me here. Really excited to be able to speak here in Warsaw. I will speak today about Swift 2's error handling. And let me shortly introduce myself. I'm Marius Rackwitz. I'm part of the CocoaPods core team. If you're using CocoaPods with Swift, you may have heard from what I contributed to it. Together with the whole team, I joined the team with the efforts around making CocoaPods compatible with frameworks and Swift, which was a nice challenge, but since then sticked around. And for my day-to-day job, I work for Realm. Realm is a mobile database, and you can use it as SQLite and core data replacement. Feel free to check it out. We have lots of great stuff on our website. Okay, so I hope you hear me better now. Let's dive into Swift 2's error handling. And I have here some example code, some perhaps heavy code for some slides, but let's make sure that we have seen how it works in practice and begin all on the same level here. So what we have here, we have a struct account, which represents a bank account, like a typical example. And in that struct, we define a subtype. It's an enum error, which implements error type, the protocol which is necessary around Swift 2's error handling. And this error enum has two different cases. One case when a transaction exceeds the funds, and one other case when a transaction is attempted with a negative amount or a zero amount, and there's the error defined, which can be thrown in that case. And we see there is an associated value with that. It's the amount, and that works with standard enums in Swift, but it works as well with the enums implementing error type, which may be an interesting detail. So our account, as we see further on, doesn't provide too much information. After all, it's just a wrapped integer, which is named here the property fund. And it provides one single method which mutates the account to withdraw money. And there we see some checks with the new guards. So if you didn't came across that yet, just read it as if with no if case, and then you see after that there's the else case if the guard doesn't apply. And an interesting detail about this guard statement, which is not demonstrated here, is if you use it for optional unwrapping, then you can use the optionals later on in your code, as the code after that would be the code which would usually be the if case statements. And here we see that the errors are thrown accordingly. So if the transaction amount is too high, then the first error case is thrown, and accordingly the error thrown. And to make a whole program out of it, here's some little further code around it, where we see some further demonstration about how it can be used, and also the, as explained, the unwrapping with guard statements of optionals. We define in the outer scope another error type, and as Swift supports name spacing and automatic namespace subtypes, this doesn't clash from the names. This is just some very, very basic command line parsing code, how you hopefully would never write it in practice, just for example purposes here. Yes, and as you see, throwing errors is basically just throwing and then referencing to a enum value. so much about that here. And putting all together, or the whole program which now does the real work, is some typical task here with mutating dictionaries, because it's based on an info plist file, or in that case it's named account plist. And we see that here we have the error catching. If you have a throwing method, you have to call it from a do catch block if you don't use one of the slightly modified try statements with other semantics. We will see more about them later on. Then you have to use the do catch syntax, and here we see the both account error cases handled, and what you always need is the last case here, catch or case in that sense. And one interesting detail about that, this do catch syntax is basically working like the switch case syntax in Swift. It's also based on the pattern matching approach, and you can even extend it when you define the pattern matching operator for your errors and can modify the semantics of it in that way. Yeah, generally, as we have seen before, with Swift 2 and its error handlings, there are now these new methods which are annotated with throws. But there are different cases for this. And when we take a look into the language and the syntax elements available, we will come across throwing, non-throwing, and rethrowing. So those are the striking words. But what do they mean? When we take a look into the book, the Swift programming language, here's the pre-release version, there's a nice explanation about what they do. A throwing method can't override a non-throwing method, and a throwing method can't satisfy a protocol requirement for a non-throwing method. Seems pretty clear, right? So, for on that said, a non-throwing method can override a throwing method, and a non-throwing method can satisfy a protocol requirement for a throwing. So, anybody want to explain what's going on here? To put it in simple words, non-throwing is a subset of throwing, which means that every non-throwing method is in case also a throwing method, but you don't see it as that, and it can satisfy the protocol requirements for that. Which means, on the other hand, that non-throwing is more strict than to define something as throwing, but you can't expect, or in a protocol you can't force the implementation that there should be something thrown. You can always say, okay, I'm safe here. I use only safe implementations. Nothing will throw an error here, and can expose that in the API, which is a nice detail. So here an attempt in modeling that in actually Swift code, how this subset relationship works. And indeed, this is actually working Swift code, or at least used to be. So we have a protocol which symbolizes the throwing function here. And as I explained, the core method here is defined as throwing. And you can even extend it in a subprotocol which is more strict and says, okay, the same method basically, but not as throwing, and it satisfies, or you can have to declare just one of those methods, and you can even just declare one of those methods. Overloading in that sense doesn't differentiate between the cases and wouldn't work as expected. You can't differentiate between non-throwing and throwing with overloading. But there was one other little thing here we didn't come across yet. how does this rethrowing fit in the row schema? So rethrowing is the shapeshifter in the row thing. It can appear as throwing. So if you define, here is the example, a little function parse which doesn't do anything different than proceed to the chars of a string char by char, and is called for every char. And as we see, the closure which is passed to it throws an error, and by that the whole function gets throwing. So when we invoke it, we have to wrap it in a do-catch block or use it in another way, but at least we have to use it in combination with try. But the exactly same method defined as rethrowing can be used with a different closure as non-throwing. So if we don't have an error, then we can use it without any error handling around it. The error, no error handling code around is needed because the compiler can use it in both variants. But there are limits to that. The closure you get in a function, you can use it only, can call it only directly and can try it only directly. So we can't do things like trying it and then catching the error, wrapping the error, or do anything like that. You can just try the closure and you can't expect too much because there could be no error. So yeah. Okay, so much to the new syntax. The next big chapter is this new error type protocol. What does this error type protocol, how does it work? What does it mean? What are its requirements? We have seen before in the first example code that I didn't need too much to do around it to implement it. Those were just some enums without any specifics around it. So here is a little real-world example from our little library, which I wrote to parse the Swift AST dump, which is, yeah, those are S expressions, not really important here. But we see it's a parser, and we have some cases here. It's like before in the first example code we have seen. As you see, you can use associated values with it. You don't need an associated value. What you can't do is having a raw value. But yeah, those are the possibilities you have. If you take a look into this standard library, comment-click on error type, you will see that that's not too much. If we inspect that on runtime with LLDB, we will see just a little more. The compiler knows a little more about it. And there are two hidden properties, which is domain and code. And those two properties are needed for the Objective-C compatibility, because you can bridge an error type to an NS error. And NS error has at least those two necessary properties, domain and code. There's also the field user info. You may remember, for whoever has here an Objective-C background. Yeah, but you have to have those both. And for the most enums or error type implementations, the compiler can figure out that automatically. Just because everything is namespaced in Swift. So from the namespacing, we can fill the domain. And the code is filled because the error type is ultimately raw representable and has a raw value. So the code is the raw value of the error, basically. And beside that, there's a little more about the error type, which you can find out if you take a look into the disassembly. of some code which uses and defines on error types. Error types are always hashable, which means that they are also equatable. And that's really easy to achieve when you're raw representable and your value is backed by a simple code. So yeah, that's needed to be able to compare errors and bridge them in an Objective-C world and interact with them properly. So here's a little example of what you can do with our new gain now. You can implement error type also in a struct. In the first betas of Swift, it was necessary to have all this code inside the struct here. Since the Xcode beta 5 of Xcode 7, they will be generated automatically on compile time, but it's nice to have them in that way, I think, as well, because if you go that far to use error type from a struct type, then you won't probably be able to set your own values for code and domain, and then you won't have this ugly underscores as prefixes all around. So yeah, in that way, you could use that, but you should be really careful and think about what you're doing there. Usually you should just use the enum implementation, but I think in rare cases it could make sense. I used it, but perhaps there are also nicer ways to use it. Yeah. So much about that chapter. But as we were figuring around with the disassembly, we can stay there a little bit and can take a look at how this new error throwing, which is baked into the language, works under the hood. Yeah, and here's some a little overview about the properties of the Swift error handling first. It breaks the control flow. It is a syntax trigger around NS error pointers, as we have seen more or less already, because it bridges to NS error pointers, and it is also from an API level fully compatible. All old APIs from Objective-C, which are exposed over bridging to Swift, can use Swift's error handling if they have last parameter with an NS error pointer. And that works because it's compatible and it's just some nice syntax around it. And we will see later on when we go forward to the disassembly that it actually used the same way. And because it's just based on the NS errors, it is also not as expensive as Objective-C exceptions. There's no unwinding of the core stack involved or anything like that. It's just another way, more or less, to have a return type with some nice syntax around. Even if it looks like Java exceptions or other exception concepts from other language, it isn't anything like that. It is more a return type, actually, and is more something like the approach seen around error with nice syntax, and as imperative approach, as it breaks actively the control flow. But yeah, let's stay around the disassembly, and here's a little program I compiled and have the binary thrown into Hopper, a popular disassembler. And here you will see on the left-hand side the pseudocode of the foo method. And as you can see, the foo method has one argument, x, an integer, and beside that it is throwing. And you see the in a pseudocode, our function has now 3 arguments. And if you will take a closer look, you will see that the last argument is actually just an error pointer again. And I didn't figure out yet what the second argument means. But it, in the end, it all goes back to the same way to handle errors like an Objective-C and stays in that way on an assembly level API compatible as well. So I don't know how it was seen from the back row, perhaps a little bit bigger. Yeah, and as the next chapter, let's speak about tests. If we bake into our programs the new error handling and make use of that and perhaps replace our result types with it, how do we test that? So one disappointing thing first, XC-test brings no support for it. It goes that far. The lack of support isn't really obvious. If you would try out to have a test case, so we have a little test case here with a throwing method, and as you may recognize, we have this little symbol here. So Xcode thinks actually this is a test. So I guess it's not using the full AST or not making the right guesses there. It is named like any usual test, but it's throwing. And in that way, XC test case won't recognize it as a test. It will never run, which is also the reason why this program here succeeds, even so the test case here defines an assert which would always fail. So be careful with that. You can't define just a test case as throwing. It won't be called. If you have run the test before and it wasn't throwing, then you may even see a green symbol in front of the test. But indeed, it isn't just run at all. So I built a little library to resolve that. It's called Catching Fire. It's on GitHub, open source. Check it out. Here a little example of how it works. Making use of Swift's emoji support. But the most important thing you will see here is on the bottom. There's our tests around trying that the disarming of bombs do work or does not work. So we have two more or less assertions, new assertions here, which use the auto closures feature of the Swift compiler. So we have an expression in the call, and the assert no throw expect that the closure won't throw. And accordingly, the assert throws expect that there is a specific error thrown. We aliased the bomb error time elapsed to fire emoji. So, and after that, again, an auto closure, just to keep it short and simple. Yeah, so much about testing. One other thing I mentioned briefly before, if you came across the functional approach around Swift, you may have seen a result type. For those who do not know what that means, it is a very specific error type which allows monadic composition. So that's perhaps not that helpful as an explanation. It's mostly implemented as an enum with two cases, a success case and a failure case. and both cases may be generic parameterized depending on the implementation you use. There's one specific popular implementation around which allows that, and in that way you can model something very similar, like what a Swift error throwing allows, and you can't also cover the case of throwing and non-throwing by having a stub type, which you can place into the error parameterization, and just saying, okay, that's a type which doesn't have any values, any legal values. Yeah. And I will run through a little comparison of those both approaches to give you some orientation about what you could settle on, depending on your requirements. So integration with standard libraries. Yeah, if you take a look around Foundation or any other Apple framework, you will see from the Swift perspective, from the Swift pseudocode, there is no error pointer anymore. So the point clearly goes to the built-in error handling. I think that was obvious. But what is about asynchronous code? As we have seen before, the try-catch model actively breaks the control flow. And it's not really suitable for anything which asynchronously calls back. So the point goes clearly, from my point of view, to the result values, which can just pass around in any way. You can take it as a parameter from closures, and yeah, you can use monetic composition, map them, flat map them, whatever you want, and chain code together in that way, and you're very flexible with that. You can do that with errors as well, but not as good for asynchronous situations. So how does those both approaches embed with the new paradigm of protocol-oriented programming? Protocol-oriented programming is centric around protocols, and we have seen before, and important for the error approach is here that they allow to support the different models. And we have seen before that non-throwing method can fulfill a throwing method protocol requirement. So I would say there is some point for the built-in error handling approach. But for the result type, you have, as I explained before, there's the flexibility to generally parameterizing the error cases of them. And by using the stop type, you can have also a lot of expression power, and you are able to generally propagate the error throwing or non-throwing behavior through classes just by the generic type parameterization, which is heavily used in reactive Cocoa 3 or reactive Cocoa Swift version, if you want to take a look into that. And yeah, you get a lot of power by using that approach. Yeah, and there it ends already with my comparison about those two approaches, and I'm lucky that I can end it with an equal match of points on both sides. I think you really have to decide yourself, depending on your requirements and what kind of code you write, whether it's very asynchronous or it is very synchronous and should be beginner friendly. It really depends, and you have to decide case by case what makes more sense for you. Yeah, and last but not least, a little chapter around code smells. Code may smell. If we have use some approach perhaps too intense, as you may have already seen in the community with the discussions around how to use optionals right. That's what it is based on, basically. So there's this thing of implicitly unwrapping optionals. If you write a exception mark behind a type, you can fall back to the type expressiveness of Objective-C, which is not as good as the type expressiveness of Swift. And we can have strong assumptions about whether a variable has a value or hasn't a value, but we would give it up with using implicitly unwrapped optionals. So for that reason, an implicitly unwrapped optional is mostly considered as a code smell, because you don't unleash the full possibilities of your compiler, and you don't really design your code around the possibilities, but give up at a certain point, which can be for specific situations fair enough. It is kind of difficult to do it right with interface builders, IB outlets, as you may have seen if you have tried to use that. But there are often ways around it. And the same applies for Swift's error handling. And I will begin with a little example here. It's a typical scenario. I think it is very often used in that combination for the first time. JSON serialization and deserialization is one of the most important things probably for mobile interacting with APIs. And here we see I think very bad code, because we use the do catch syntax, but do not care at all around the thrown error. This could be done a lot better with what a Swift syntax offers us. There's this one thing which exists already in the yearly betters. It is try exclamation mark. And so you see, you don't have to wrap it in a do catch statement. But on the other side, you have an implicit assert here at this place. If you would map that mentally to Objective-C code, it would be like defining error variable, passing the pointer into the method, calling the method, and then making an assert on the variable that is not that is nil, and there is no error. So yeah, be aware of that, that there is an implicit assert. I think in the most I/O cases, like in this specific combination seen here, it doesn't really make too much sense. If you handle arbitrary JSON code, for example, and rely on something you don't have control of. If you deserialize just your own fixtures, and you know to every given point in time that your fixtures are valid JSON, you could use that theoretically. If you make sure that there are no other possibilities where this call could fail. So sometimes, yeah, it's hard to make safe assumptions about when a method can fail or not, because it's not always documented in a way that you can really be sure what's going on there. But it really depends on your use case. Before we see what the other possibility would be, because that seems like more the way how you would do it mostly in Objective-C, using the new try question mark syntax, which is demonstrated wrong because there's an error in the example code here. Read the exclamation mark as a question mark below. So works basically like try, but if there's an error, you will fall back to a nil value. So it wraps the core basically in an optional. And if it fails, then you get just no value. And that means that in the end, you have to handle your optional case. And if for some reason a non-result is something valid for the method, which doesn't mean it was an error. So you could imagine a throwing method which has a optional return value. Then you have to use care with that, because you won't be able probably to figure out, or you have to use care in a situation that you don't run in the situation where both events overlap, because you have then a further layer of mapping or wrapping of your result type. But yeah, in comparison to what we have seen before, from the effects, you can handle both cases with if and else. You are not able anymore to figure out which error occurred. So for do catch, block has still, in comparison, the advantage of being more explicit about what's going on here, because if and else is just used in very broad meaning, and do catch is more striking, and you will see when someone falling into your code base reads it, then it's pretty clear what's going on there. That's code which handles errors, even if the catch case is just a catch-all. And yeah, if you chain multiply error or throwing methods, you have further advanced with the do catch syntax in comparison. But try exclamation mark and the try question mark syntax are only as good as their adequates for optionals. So especially try exclamation mark is only as good or as bad as force unwrapping optionals. Sometimes it can make sense to force unwrap an optional, and sometimes you really shouldn't use it, because if you don't use it with care, you will crash the app, and that's really an undesirable event for the user. I mean, we are all aware of that, and we have been all in a situation of the users. We should avoid crashes. Yeah, and again, try to use that which makes more sense. Don't write just boilerplate code around error handling just for the sake of doing it right, and avoiding the try exclamation mark. If you can make stronger assumptions. Yeah. And some further takeaways finally. Avoid try exclamation mark because of the crash. But prefer it or the try question mark syntax instead of just an empty catch block. A further little thing which we haven't seen, especially this JSON serialization, deceleration scenarios, the errors thrown there can be catched with errors cases exposed about NS core error, which is no enum, for example. As we have seen, it's possible to use error types with other syntax elements in Swift. NS core error has static functions to construct the error cases, which you can use to catch the cases. And always try to use that if there's a case which makes sense. Sometimes it's hard to figure out the right case because the name are cryptic, like a JSON deserialization error may be something like property list is malformed. I don't know the exact name, which makes the point clear, I think. So it isn't necessarily related directly to your method, and you will have perhaps sometimes problems to figure out the right case. And if it's not exposed at all, or it is not obvious enough, then fight a radar about it. I think a member of the Swift team explicitly asked about that on Twitter. So if you come around something, yeah, give Apple a shot and give them a signal that there is potential for improvement. And finally, give it a try. So, are there any questions? If there are no questions now, then feel free to catch me later on and just ask me one-on-one if you think your question is better placed there. And otherwise, thanks for your attention.